during the real exam because it's a tool that you need to use during the real exam, and it's called dimensional analysis. So we'll talk a little bit about that, and then just like for all of our webinars, we always use some problem-based learning. So after we discuss it a bit, then we're going to try some practice questions, and then we will go through the work solutions together. Before we begin, if you don't mind sharing where you happen to be in the world today, you can put in the chat what city or town you happen to be in today. And then everyone will know we're about to get started. Okay, great. From West Australia to South Australia to the UK, the US, and Ireland. Okay, wonderful. So, you might be looking at this cover from the Master Series and wondering, why does it say maths and physics? Why doesn't it just say physics? Is mathematics really one of the topics for GAMSAT? Well, um, uh, this is a poorly kept secret about the sciences section of the exam, and that is that mathematics is more important to your score for the sciences section than physics or general chemistry or organic chemistry or biology. Incredible. So there are more questions that are based on mathematics than require assumed knowledge from any of the four standard sciences that you are considered to be responsible for. And of course, the conventional way to talk about GAMSAT is in terms of the three sections of the exam. The humanities section, sorry, formerly known as section 1, the written communication, formerly known as section 2. And I say formerly known because in 2024, for the first time ever, section 2 was section 1. So ACER has a new timing for the exam, in that you're going to be sitting the written communication at home, so with an online proctor, before you sit the two multiple choice sections. And those sections, most of you will be sitting in a test center, using a computer. But if you are more than 3 hours away from a test center, then you will be able to sit the multiple choice sections also at home. Perhaps someone can type in the chat that I'm not muted and that someone is probably don't have their speakers. Okay, welcome. No problem. Okay, so we're going to be talking about what was formerly called Section 3, which is the sciences section, and in particular, physics. So more or less, the exam is divided this way in terms of the sections of the exam. So physics is literally as important as general chemistry or organic chemistry, but as I said before, it's mostly mathematics. And we're going to see why that is the case. And later in other webinars that will be taking place in the weeks and months to come, we'll also be examining biology, and you will also see that most of the biology questions are based on graphs, tables, diagrams, and mathematical relations. So again, even for biology, a very important number of the questions are based on mathematics. So those are skills that you want to make sure that you have. And by the way, I'm only talking about high school or secondary school level, and there's no calculus. It's just very basic algebra. But there's also graph analysis, which is, well, let's just say that you need to practice in order to see the types of questions, because Acer is able to ask questions in a way that a graph that might look relatively straightforward can have its own little secrets. Okay, and in terms of I'd like you to be able to see some commentary that some students have left in public forums after they sat the exam. So I'm going to let you read this little section here, and then we'll continue. When you're done, just type "done" in the chat, please. Now, to be clear, everybody's going to have a slightly different experience with the exam. This is partly due to the fact that everyone has a different academic background. And so what they notice will be different from student to student. But also, each exam, all the exams, even when you're sitting the exam on the same day as another student, many of the exams will have differences. So they might have a different unit. They might have some different questions. They might have very similar questions, but different numbers. There's all types of ways in which standardized exams have internal security. So that's just normal. However, the general sense of the exam is that there's a foundation of mathematics, and it's very important for you to get that clear. Now, you can get your mathematics from many different sources. You know, I'm not trying to say that the GAMSAT Masters Series is the only place that you can get math, but we do have some features that you might find helpful. So one of the things that we do is we calculate all the past real exam questions that Acer released, and then we look at how much of the information on those exams for each question had assumed knowledge for a certain type of mathematics. So a chapter like this, you know, basic numbers and operations, 13% of Acer's questions. Okay, so those aren't our questions. These are based on past exams. But the most important ones in terms of chapters is chapter 2 and chapter 3. In fact, chapter 2 and chapter 3, chapter 2 being at 11%, and then chapter 3 being at a unbelievable 65% of questions from section 3, and it's because it's algebra and graph analysis. And that shows you how important algebra and graph analysis is to this exam. In terms of what we're going to be looking at today, we're going to have a separate webinar on graph analysis, but today we're looking at dimensional analysis, which is a very important tool. It's so important for this exam. I know this is going to sound hard to believe, but dimensional analysis is a tool that will help you to solve some questions on the real exam, even when you don't fully understand what the question is. You may not actually understand everything that they're talking about, but you can still solve the problem because of the units. Because the exam is provided, they're going to provide joules or watts or something in terms of the units, and then you're able to convert the units into different units because they give you certain units in the question, and then they give you other units in the answer choices. And so even if you don't fully understand what was the mechanism or what was the experiment, you can see that there's going to be a conversion of units that's going to be required. And of course, it's going to require some, for some of you, revision. For other, it's going to be learning what the basic SI units, which is the Système International, the International System of Units, to know what the basic units are for physics, for general chemistry, and basically those are the same ones that apply to biology, and to know what those units are so that you're able to make conversions. And then the tool that's used is for dimensional analysis is using fractions in a way to make conversions. And here's a sort of a very simple example of it. And you may remember from your very, very basic algebra is that you can multiply anything by the number 1 and you're not changing it. It seems like an obvious thing to say. You can multiply anything by the number 1. But in so doing, you can create fractions in order to convert units. So, for example, we all know that in 1 hour, there are 60 minutes. So this can be written in 2 different ways as a fraction, either 1 hour over 60 minutes or 60 minutes over 1 hour. Now, in a given problem, you might use this or this. It depends. It depends on what you start with and what you want to end with. And so it's still going to be a simple multiplication of a fraction multiplied by some number. And then you will be able to cancel units. So if you multiply this by 5 minutes, for example, in order to know what fraction of an hour 5 minutes is, if you multiply this by 5 minutes, this is the number 1. So I'm allowed to multiply the number 1. I'm allowed to multiply any number by this because it's equal to the number 1. And if I multiply 5 minutes times this, then I'll be able to cancel minutes and I'll end up just with hours. But if I have a certain number of hours and I want to know how many minutes that would be, if I have this certain number of hours, then I would want to multiply this by whatever number of hours. So I can cancel hours in the numerator and the denominator, and then I'll end up with a certain number of minutes. So that's what dimensional analysis is. It's just analyzing the units in order to cancel some units in order to get a different set of units. And knowing this simple tool, it's going to be very helpful. Now, for some of you, this might sound theoretical if you haven't used it before, but don't worry, we'll definitely be using it. So that's dimensional analysis, which we'll be talking about. And then, of course, later in the weeks or months to come, we'll be talking about graph analysis, looking at different types of graphs. Some of them are 3-dimensional, some of them are logarithmic, which is a very common type of graph that Acer likes to use. Logarithmic graphs or curves, and some of them are type of graph that is called a nomogram, which is a graph that has 3 or more different either axes or variables with the graph. And that's another type of graph that Acer likes to use. So it's not advanced math, but it is, going to be the foundation to understanding Acer's GAMSAT Physics, General Chemistry, and Biology. Only organic chemistry has a different set of ideas that you need to learn, but that's a different story. Now we're going to move on to some multiple choice questions. So we're going to be completing 5 multiple choice questions. I'm going to ask my handy assistant to put the PDF in the chat. And if you're watching this later, it'll be in the description, the link to the multiple choice questions. And it starts with a little blah, blah, blah. It's nothing that you need to read now, but we do have a free medical school interview program, which you can use at any point, and there's not you pay for more or anything like that. It's always going to be free on the website, and it teaches you about the questions and answers that you might be exposed to in the future. But right now, we're going to start with the second page of your handout. And that's where the multiple choice questions begin. And the current timing of the exam is actually, you have 2 minutes for each multiple choice question in section 3. So for the sciences, you have 2 minutes per question. But these 5 questions that you'll be doing today, because these are warm-up questions, each question is still standard of the exam, but there's no passage. And often on the real exam, there'll be a passage which will slow you down, and you have to get an idea of all that. But there are also these types of independent questions or discrete questions that appear occasionally on the exam. So these are the types of questions that we're looking at. So you're not going to get the full 2 minutes per question. You'll have 1.5 minutes per question, but on the real exam, it'll be 2 minutes, but there will be passages. So that's why you'll have 7.5 minutes or 7 minutes and 30 seconds if you want to use your dimensional analysis. I will be putting some hints up once you get started. I'll put a few hints, not for every question, but a few hints. And I'll leave it here because understandably, some of you are right at the beginning or you have a non-science background, and there might be just a couple of things to fine-tune your understanding, hopefully. Hopefully you've done a little bit of reading, because obviously if you've done absolutely nothing and you've never heard of physics before in your life, then even the hints will be challenging. But if you have done a little bit, then first try the questions. If there's a question you can't see how to start it, then look at the hints and then see if that helps. And if you have done some studying, then don't look at the hints until you finish the questions. Okay, so can we get a 7.5 minute clock or 7 minutes and 30 seconds? And we'll get people started, and then I'll put the hints. Okay, Viv, if we can have that clock started, please. Okay, perfect. Great. So start now and good luck. Okay, so that's time. For the first question, A, B, C, or D, you can put your choice in the chat. Okay, so we're told the refractive power of a lens is the inverse of the focal length in meters. So we're just going to take the information that's provided to us. I mean, some students may have memorized such a thing, but in general, ACER is not going to require you to have memorized such a scientific fact. It's not going to help for the real exam, but they're providing the information. So they're putting in English what we need to convert into an equation. So it's power of a lens in diopters, and diopters is going to be the units we're looking for. So we're starting our dimensional analysis, our analysis of units, and then the power is equal to is the inverse of the focal length. So it's 1 over the focal length in meters. So this has to be in meters, and then this will provide the power in diopters, which is going to be the answer. So what do we have? We have 0.5 centimeters, but a centimeter is 1/100th of a meter. Centi is referring to the 1/100th of a meter. So we have to put the focal length in meters. So we have 1 over, we have 0.5, but it's times 10 to the minus 2 to make it meters. If I just put 0.5 here, it would be in centimeters, but that's not what we're told. The focal length has to be in meters. So I put 10 to the minus 2 in meters. So now looking at this, so this is minus 2, I have 1 over 0.5. So 1 over 0.5 is just the number 2 because 1 is twice 0.5. So this is the number 2, and I have 10 to the minus 2 in the denominator here. And to bring this upstairs, we change the sign of the exponent. So that's just basic algebra. And don't worry if you didn't remember things like that. Um, you just need a few weeks to practice the basic algebra, and then you'll be fine. So what number is this? We were told if this is in meters, then this is in diopters. So this is in diopters. And so we have 2 times 10 to the 2, that's 200. And so, yes, there's a lot of correct things there. And I know you might look, for some of you, of course, you're just starting to do your practice. So you're just starting to get into the habit. For others, you might look at this and say, oh, it's trivial. But on the real exam, there are questions that are as simple as taking the inverse and changing units. A classic question with regards to that is frequency and the time period. So frequency of a wave, for example, and the period, they are inversely related. So sometimes ACER will give a number in megahertz or some sort of not just directly in hertz, and getting you to convert into hertz, the basic SI unit, just like we converted centimeters to meters, which happens to be the SI unit for length. And so this is a very common type of thing. Convert to the SI unit and then do the calculation. So it's just a little routine that you would want to get started with. And next, so this one, you got a little bit of a hint, just in case. And, or no, that's the next one you got a hint for. This one does not require a hint. It requires disciplined dimensional analysis. So which of the following is most consistent with the average rate of increase in the height of a person from birth to 20 years old? Now, I know this sounds absurd looking at a question like this. Acer had a question in which they asked for the rate of growth of fingernails. Yes, your fingernails, without giving you any basis to make your choice other than the answer choices. So they didn't say, well, the normal growth of fingernails is blah, 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 and now calculate. No, they gave no information. They only said, you make the basic assumptions in order to calculate the rate of growth of fingernails in meters per second. And so, and that question, by the way, they had that as a question on the exam for about 10 or 15 years. It was giving giving students conniptions. But the idea, the question on the next by the way, the only reason I'm able to talk about that is because Acer released that question. So it was a question that was used for many years, and then they released it in one of their practice exams that contain actual past GAMSAT questions. But so the concept remains the same, is that you're not given the information as to how to start the calculation, but you're given just enough, and then you're given these answer choices. And these answer choices are very, very different because the difference in the exponent is 10 to the power of 2. That's 100 times different. So that means each answer is 100 times another answer. And that means that you can make really wrong assumptions. You could be off by 30%, 40%, 50% in your assumptions, and then you'll still get the right answer because the answer choices are crazy in terms of their differences. Okay, so obviously, in terms of rate of growth of a height of a person from birth to 20 years old, I don't know the answer. I don't know what that is. But what I can do is I can start with one of these and I can see what does it give me. Because if it gives me a person who is 100 meters tall, obviously that doesn't happen. There's no human being who's 100 meters tall. And then if it gives me an answer that's 1 centimeter tall of growth during that period of time for an average person, I know that's also absurd. So I'm just going to look to see which of these answer choices can give me something that is plausible. Okay, so let's set it up. I'm going to take the first one randomly and see what that gives me. And yes, you can put your the answer choice that you've chosen in the chat. So I have 2 times 10 to the minus 7, which I'm taking from here. And now what I'll do, I'm going to do a series of calculations in order to find out how many meters would that give me. So for a person after 20 years, how many meters would it be? And as I said before, if it's 100 meters or if it's 1 centimeter, I know that that would be incorrect. So I have 2 times 10 to the minus 7 meters per second, and I'm being careful as to use dimensional analysis. And now I need to get this up to years. Why to years? Because the person's 20 years old. So I need to convert these seconds into years and then into meters so I can make a logical decision as to reasonable or unreasonable. So I have meters per second. Now, in order to convert seconds to years, I need to convert seconds to minutes, minutes to hours, hours to days, days to years, and then I will have it. So this is dimensional analysis going step by step. I'm going to continually multiply this by the number one using fractions that show real actual ratios. For example, I have seconds here. To get rid of the seconds, I will need seconds in the numerator. And I know there's 60 seconds in a minute. Then I'll need to get rid of minutes. So I'll need minutes in the numerator. There are 60 minutes in an hour. Then I'll need to get rid of hours. Again, 24 hours in a day. Then I need to get rid of days. There are 365 days in a year. And then finally, I need to get rid of years. Well, this is over a period of 20 years. And therefore, years cancel, days cancel, hours cancel, minutes cancel, seconds cancel. I end up with meters. And that's what I wanted. Okay, let's say you didn't do this. Okay, I would like to give you 30 seconds for you to make this calculation. No calculator, because part of the problem is setting it up. We have completed the dimensional analysis. The analysis of the units is done. We know that this is going to give us a response. But the other issue is mathematics. You see, you're not probably used to doing longhand calculations. So even if it was simple for you in primary school and secondary school, because you haven't been doing it very much, there might be some rust. And that means making simple errors. And also, it means not knowing when you can make estimates or approximations, because GAMSAT requires that you know when you can do approximations and when you can't. And here's a hint. These numbers are 100 times different. They're not off by 1% or off by 1 decimal point, in which you have to be very precise in your calculation. But when they're so different, you know you can make some reasonable estimates. Okay, so I'm giving you 30 seconds right now. If you haven't done the calculation, please try it, and then we'll go through it. Okay, so let's have a look at this and see how easily it can be done. So this calculation can easily be done in less than 30 seconds. And it starts with assessing, as I said before, um, how close the answer choices are, and therefore what estimates I can make. Because doing a calculation of 24 times 365 is going to take you, it's going to take you a little bit of time, and you'll be wasting that time because you're trying to be precise, but the answer choices are not precise. So there's no need to do that. So 24 it'll be easier for us to consider the number 25. It's a slight difference. 365, we'll round that up to 400. Why can I change by a 10% or something? Because these answers are not 10% different. They're 100 times different, which is insane how different they are. So these slight modifications will make no difference. Even if I chose 500, it'd make no difference to the answer that you would end up choosing. Okay, and then I have something very easy, which is 25 times 400. So I know that 25 times 4 is 100. And then I have two extra zeros, 1, 2. So 25 times 4, 100, and two extra zeros. So I've crossed that out. Now let's see what we're left with zeros. I have 1, 2, 3, 4, 5, 6, 7 zeros. And here I have 10 to the minus 7. So that means these 7 zeros get rid of 10 to the minus 7. So all the zeros are gone. What am I left with? I've got 2 times 6. So that's 12. And then I have a 6 here, and I have a 2 left over here, and that's also 12. So this set of uh, calculations that might look intimidating when you first see it, it reduces to 12 times 12, which is 144. So very simple. And that's the level of the mathematics that you're generally going to do, except for when you have logarithms. That's a separate issue. But besides that, basic algebra, it's not going to be more than this. So we have 12 times 12, which is 144. Did you gain 144 meters since your birth? No. Okay, so that's longer than a football field or pitch. So that's not going to happen for any human being. So what about 1/100th of this? So instead of 144, what if it was 1.44 meters? Ah, now we have something that is rational. Because don't forget, we're going to be comparing this to 0.01 meters or 144. So approximately 1 centimeter. So how much did you grow? Did you grow 1 centimeter from birth to 20 years old? Or did you grow 1.44 meters? Or did you grow 144 meters? So therefore, you don't have to know the precise amount, but you can see there is only one best answer. And it has to be 1/100th of answer choice A, and 1/100th of answer choice A is answer choice B. So indeed, the answer to question 2 is B. Any questions about that? The mathematics or the dimensional analysis? Okay. So let's move on to question 3. So we have a current of 2 amperes, which is passed through a wire. So amperes or amps, that is an SI unit. For 1.5 minutes, how many electrons pass through the wire? And we're given the charge on an electron being 1.6 times 10 to the minus 19 coulombs, or C. And you were also provided a hint for this. Okay, so did you get an answer for question 3? A, B, C, or D? Okay, so the hint that was given is that current is defined as charge over time. Now, Acer would probably say that you don't have to memorize that because it's too fundamental. Uh, for example, if I went to you and I said, look at the river that's flowing. Please tell me, what is current? Now, you might fumble for a little while, but eventually I think you would come up with the idea that current is the amount of water that is flowing past a moment per time, per given unit of time, or more colloquially, over time. So it's the amount of water that is flowing over time. And that indeed is current when you're talking about water. So if you're talking about electricity, one would assume that if you've done just very basic, a study of electricity, that you would understand that that what is moving in a wire is charge. There's a charge moving in the wire. Of course, that charge could be on an electron, but that's not relevant for this moment. But there's a charge that is moving over time. And so that is the idea. The current is charge over time. And then in units, because part of our dimensional analysis, the current is in amperes, the charge is in coulombs, and the time is in seconds. So now let's use that information step by step. So first, current is charge over time. So that means that if I multiply both sides by time, I would get current times time will give me the charge. So that's what I'm going to use. I'm going to use the current multiplied by time. Now, the other thing that I mentioned is that you need to know what the SI units are. So we have amperes, okay? It wasn't hidden from you. We have amperes, we have coulombs. It was not hidden from you, but this you really need to know. And it's also suggested here you'll see that velocity is often given in terms of meters per second, acceleration meters per second squared. There's a reason for that. It's because meters is the SI unit for length and seconds is the SI unit for time. So we are given 1.5 minutes, which we know to be 90 seconds. And that needs to be converted. Because we're dealing with amperes, coulombs, SI units, we have to make sure that this is in seconds. So now let's set up our calculation. We have 2 amperes times 90 seconds, and that's going to give us 180 coulombs. Now, we need to convert this charge on an electron is equal to 1.6 times 10 to the 19 coulombs. We need to convert this into a fraction, which is the number 1. And that's easy to do. We just, it's on an electron, so then we can divide both sides by an electron. And then we would get the fraction of 1.6 times 10 to the minus 19 coulombs per electron. Because that's going to be equal to the number 1. If I divide both sides by electron, then it's going to be 1 equal to that. And remember, you can multiply anything by the number 1, you can divide anything by the number 1, and you don't change what you've originally started with. And that's the value of a dimensional analysis. Because we're asked, how many electrons are there? Well, we have 180 coulombs. We know how many coulombs in an electron. Therefore, let's take 180 coulombs. Let's divide it by, 1.6 times 10 to the 19. I'm going to add here and subtract there. So this is another way of writing this. We can write this as 160 times 10 to the minus 21 coulombs per electron. And you might wonder, why did I just do that? So I'm making some projections. I have 100. First of all, why would I divide it and not multiply it? It's because If I divide by this number, which is the number one, because it's a coulomb per electron, if I divide by this number, I can cancel the coulombs. Then electron is in the denominator. And you could cross multiply, or you could remember the little song, the denominator in the denominator is the same as the numerator. And so this is going to give me the number of electrons. And that's why I set it up this way. And then I change 1.6 times 10 to the 19 to 160 times 10 to the, because I have 180 over 160, and I know that's very simple math. So I decided I'm going to move the decimal over twice, but then if I add here, I have to subtract here. So I added 2 spots. I subtract 2 spots here. Minus 19 minus 2 is minus 21. And this makes the math very simple, because if I have 10 to the minus 21 in the denominator, if I bring this upstairs to the numerator, as we said before, that is going to change the sign on the exponent. So the 10 to the minus 21 becomes 10 to the 21. This is going to equal the number of electrons, because coulombs are going to cancel. Then I have 180 over 160. Well, it's close to the number 1. So let's look at the answer choices. 10 to the 21. There's only one answer choice that has 10 to the 21. And this 180 over 160 is a little bit more than the number 1, right? Because if it was 160 over 160 is 1. So it's a little bit more because the numerator is a little higher. So I'm able to choose answer choice A without doing a very precise calculation, but being very careful with the exponents, because that's the biggest difference. So indeed, the answer to question 3 is A. Any questions? Okay. So now let's move on to question 4 and 5, which are related in terms of understanding. And you also were given just some hints for questions 4 and 5. And that is various ways in which, in classical physics, energy can be presented. So these are equations that students often, will memorize in very basic physics. That the sciences that ACER suggests that you should be familiar with for the real exam is introductory level university for biology, general chemistry, and organic chemistry. You don't even need to know most of the information, because a lot of the information will be provided to you during the passage, but that gives you just a general idea. But for physics, it's the only subject that they say it's more grade 12, A levels, leaving certificate kind of physics. And even for the real exam, it's more basic than that. But at that level, that sort of high school, secondary school level of physics, these are some very basic, important equations. And sometimes ACER will have questions that you would have had to have known one or more of these equations in order to answer the question. Sometimes ACER will give these equations, but it depends. So the two ideas here is that for energy, there's kinetic energy, which is 1/2 mv squared. That's 1/2 mass times velocity squared. There's potential energy, which is mgh, mass times gravity times height. And then there is work, and work is force times distance. We actually have a really nice video on work and energy that we put on YouTube, so you can access it for free. So you can look at our gold standard GAMSAT YouTube channel later and look for the video on energy. It was just released a couple of months ago, and it will go through these equations. But these are very basic equations. And then there's one of the most famous equations in classical physics, which is Newton's second law, and that's force in units of newtons, no doubt, is equal to mass times acceleration. So that's mass in kilograms and acceleration in meters per second squared. So these are a little bit of background information in order to get to the solution. So for question, I'll just read the preamble first, and then I'll get your answer. So we have a material measure of heat energy, which is Q. So we have heat energy, Q, measure of heat energy, Q, the specific latent heat of a material is a measure of the heat energy per mass released and absorbed during the phase change, and defined through the formula Q is equal to mL. So this is the equation that we are provided. Secondary school, some students memorize that, but we don't have to worry about that. Now, I have to identify our first trap. Now, this was clearly defined for us as Q is heat energy, M is the mass, and L is the latent heat. Okay, so that was clearly defined in the preamble. However, I want you to notice that later in the preamble, we also have length with a capital L. So Acer once had a question where there were three things that could be symbolized with the letter T. There was temperature, there was period, and there was time. And you could imagine that a person might understand the basic mathematics or understand how to do dimensional analysis, but confused one or more of the variables. And so it's not just a matter of chug and plug, where you can just find the formula and just put something in there. You have to be very attentive as to what are we talking about? What is this L? What is that T? Et cetera, because that will also be a set trap. By the way, if you chose an answer for question number 4, you can put that in the chat. Okay, so I'm going to reassemble this because we know that we're looking for the dimensional formula for specific latent heat. So we're looking for the dimensional formula for L. So L is Q over M. So I'm just rearranging this by dividing both sides by mass and canceling mass. So I have L is Q over M, and I know that Q must have the same dimensions or units as energy, because Q is heat energy. And we already saw that heat energy can be any of these. So I can replace Q from a dimensional point of view, meaning the units, with any one of these three equations, and I'll get the same answer. I have to get the same answer. So any of these three would get the same answer. So I'm going to use 1/2 mv squared. So I've replaced energy with energy, and this is over m. Masses cancel, and I end up with v squared. Now, I know some of you are going to say, what happened to the 1/2? Does the 1/2 affect the units? If you have 1/2 Newton or 10 billion newtons, does either of the numbers in front of the units affect the fact that it's newtons? No. And what this question is about is finding what are the units. Okay, so what is the formula? So the 1/2, you can put it, you don't have to put it, it doesn't make any difference. So we have v squared. Now, what is v squared? Well, v squared, v is meters per second. So this has meters squared over seconds squared. Meters is length. So that's length squared, and seconds is time over time squared. And that is answer choice D. D is in Donald. So that's L. Remember, change the exponent if you bring it upstairs. So that's -2. And look again. Do you see over here? This is meters. And over here, it's mass. Context is everything. Okay, so we were given this equation with mass. So we know what that is. But we know that velocity is meters over second. And I know that can be frustrating to some non-science students, especially when they're studying physics for the first time and they notice that there's many different variables given to the same idea. For example, you're going to see length symbolized by L for length, but you're also going to see length symbolized by D for distance, sometimes small d, sometimes capital D, and sometimes for displacement, capital S. Yes, S is in Sam. And then when you do optics, distance is I, O, F, R, all for different contexts of distance. And so you're not supposed to try to memorize letters because you're supposed to have a sense of what the idea is. So once you do, for example, potential energy is based on height, you know, how much potential something will have to, say, crash if you drop it. The higher you put it, the more it's going to crash when you drop it. So it has more potential energy. And what does that energy depend on? It depends on its weight and the height. And that is the equation for potential energy, mgh, because by definition, m is mass, but weight is mg. So mg times h is potential energy. So if you have the idea of what it means, then you're not going to get tripped up on different letters, multiple different letters in the same problem. So, and that comes with experience of doing practice questions. Okay, so 4 is indeed, D is in Daniel. I think I prefer Daniel than Donald because of American politics. And going on to number 5. So now we're given an equation where F is the force and T is the time. What are the dimensions of A and B, respectively? Okay, so hopefully you have a little bit of a concept now as to how this MLT stuff works, you know, mass, length, and time as defined in the problem. Don't forget, the problem is defining that this is M is, these capital letters are mass, length, and time, and the example of velocity, meters per second, is L over T. So obviously meters squared over second squared would be L squared over T squared, which is what we determined. Okay, so now we have newtons. And if you did come up with an answer for question number 5, you can put that in the chat. So we have our equation that force, how it is related to time, but we don't know what the dimensions of A, which is here, and B, which is here, must be. So let me just rewrite that equation. T to the -1 plus BT, and that's squared. Okay, so what I can say for sure is, okay, I have no idea what the units of A and B are. I do know that this is time. Okay, so that in SI units, that would be seconds. And this is time squared. So that's be seconds. This is the inverse of time, of course. And I don't know what the units of A and B would be, but I know the units of this, and this, because that's force. And force is in newtons. So I can determine what newtons would be in these in this new system that Acer might present to you, which it's not new, obviously, but in terms of mass, length, and time. So first, what I'll do is I'm going to figure that out. And to figure that out, I'm going to say that force is the most famous equation for force is that force, Newton's second law, is mass times acceleration. And mass would be capital letter M, and acceleration is meters per second squared, as an example in SI units. So acceleration is meters, which is length, per second squared, which means per over time squared. So this is the mass, and this is the acceleration. So I can change force to this. And remember, I know what T is, so I should be able to easily calculate A and B. But first, you need a concept. And that concept is apples and oranges. You've heard this many times, but now you're going to see a clear example where this applies. And you've heard the expression, you can't add apples. You add apples to apples and oranges to oranges, but you can't add apples to oranges because the units are different. And here we have two things being added. I don't know what the units of A and the units of B are, but I know that this must be in the same units of force, and this must be in the same units of force. The only reason we can add this to this is because they're in the same units as this. That's the key. So whether or not this is adding or subtracting, it's only possible because they're the same units. Obviously, you can multiply things that have different units. You can divide things that have different units, but when you add or subtract, they must be of the same units. So I'm going to take this problem each separately. I know that this, in terms of units, must equal A time. Okay. So now what I'll do is I will divide both sides. Oh, this is time to the -1. Sorry, time to the -1. So that's like putting time at the bottom. So in order to find out what A is, I need to isolate A. So I'll multiply both sides by time. If I multiply this side by time, time cancels. If I multiply this side by time, one of the times cancel, because this is t times t, it's t squared. So t times t, so if I multiply this side by t, one of the times cancel. So I end up with ml over t. So you already see what the answer must be. The answer must be D, because it has ml t to the -1. And so this is the correct answer. But we're still going to do this one just for fun because you're enjoying yourself, hopefully, or perhaps later. Don't worry, this is recorded. So if you're having problems with the mathematics, you can look at it later. And also know that we have a forum. The forum's free, and you can post any question that you have in any of the content that we do. So I'm taking the F again. Here's the force again, but this time I'm equating it to B and T squared. So this is T squared. So now to isolate B, I'll need to divide both sides by T squared. So if I divide this side by T squared, I get to isolate B. If I divide this side by T squared, well, then I'll have ML T squared and another T squared in the denominator because I divided that side by T squared. So when you have the same base, you add the exponents. So this is the same as T to the power of 4. And because it's in the denominator, if I want to bring it upstairs, I change the exponent to T to the minus 4. So I have ML T to the minus 4. Again, answer choice D. And you have completed Introduction to Dimensional Analysis. I hope you found it helpful. We have monthly free webinars. When the exam approaches in August, we'll actually have a free webinar every 2 weeks. We also have tutorials every weekend going through July, August into September. Those are tutorials, they're a little longer. And so those are things you can consider. And if you don't get the physical book, you can also go to the library. There are many libraries near you, yes, in Ireland, in the UK, and across Australia that have the book. And so you can consider that. And the ebook is currently on sale on the website for half off. So other things you can consider. That's it for today. I hope you found it helpful. I'll see you in the next one. Good luck with your studies. Bye for now.